We are getting to the heart of the matter with the first technology field about energy efficient chips. And so I'm calling Cécile from Soitec, and she will speak about RFSOI technology. And we will see that 5G is spreading far beyond smartphone. So I let you speak.
And this is for 5G and beyond the application. Okay? So I will start the presentation with explaining what is the 5G technology and the new radio standard. Then I will show you what are the challenges associated to this application for the sub-6 gigahertz and millimeter wave application. And I will focus on the RFSOI current product, but also the new product we are developing. So you are probably all familiar with these 5G technology numbers, but just for those who are not familiar with them, so 5G actually, the promising is to have a huge capacity increase of the network by 100 times more than the current 4G technology. Then we will have 10 times faster response, 10 times more speed, and we will also have 10 times more connected devices. But we will also have less energy by 10 times per data rate. So in terms of 5G roadmap, you have different standards. So, the first one was release 15. Then, so it's dedicated to smartphone application. Then, so it was released in 2019. The release 16 was now released for the smartphone, but also all this kind of V2X application. And the release 17 is dedicated to further frequency application above 60 gigahertz application, what we call the millimeter wave application. So beyond the smartphone, this 5G application can enable the automotive applications such as autonomous driving. So all this kind of connection between two cars connected to each other. We will have also access to 5G connection for IoT devices, for your smartphone, for instance, and security or healthcare application. And also 5G will enable the automation, the easily automation of in the industrial 4.0 application. So in terms of challenges and requirements, especially for the substrate, so on the top-hand side, you have the need of having access to high data rate and higher spectrum efficiency and capacity. So for that, we need to have high linearity switches, so higher performances. And I will explain later on how we can have this kind of performance on a specific substrate. On the lower side, for IoT application and smart home, what is really important is the cost of these small devices connected to each other. So it is a cost-sensitive application, and you need to have what we call the good enough switches performances. And the last point is about the reliability into cars. For instance, if you have some connection inside the car and close to like an engine, which is at a higher temperature, we need to have this kind of connection devices reliable even at higher temperature. So for that, we need also some specific substrate dedicated to this application. So if we go back to the 5G cellular evolution, so here it's kind of on the top-hand side, you have the mid-tier phone and high-end phone. So all these devices are located in the, so I don't know how it doesn't work, the laser, in the front-end module, so it's here, actually. So in the front-end module, you have different components, which are different devices, like low noise amplifier, power amplifier, and switches. And for the 5G application, because you will have other bands and so on, you will have additional feature and devices, and these are the one actually highlighted in orange. So you can see that in like mid-tier phone and the high-end phone is like all the most expensive phone, like all the Apple phone and so on. So you will have an increase in terms of components inside the phone. So that is driving also the number of, you will see, but SOI millimeter square you will need in the phone. In addition to this sub-6 gigahertz application and frequency, you will add the millimeter wave application. As mentioned before, millimeter wave application is more for having a larger band and higher frequency range. So it's between 28 gigahertz and 39 gigahertz. And you will add also some additional device into your phone. So what is important in terms of substrate? You all know and familiar with this Italy tower, and you can see that the foundations are really key, right, to any building. So now that's the reason why actually substrate is an appropriate substrate for to guarantee and secure the performances of your device. Another important point is the trade-off between the performances, power, area, and cost, as mentioned before by François. At the beginning, all the switches that are really a main component of the front-end module in our smartphone was built on the GaAs material, so gallium arsenide material. But the cost was really high. Then they switched the technology to a silicon on sapphire substrate, and RFSOI bring like we reduce by 2 times the cost of this kind of device built on RFSOI. That's the reason why, actually, starting in 2014, you can see that the RFSOI was the main technology used for this main antenna switch technology, and right now is the standard for this application. So here, as mentioned before, RFSOI now is in all our smartphones, and it's a substrate of choice for this application. But then, if you have 5G application, 5G networking, you will increase the content of SOI by, so you will double on standard phone, and for high-end phone, you will also increase the quantity of SOI millimeter square in your phone. And now, because you will add some millimeter wave application and frequency, for instance, you have like 3 antenna in package per smartphone, so it will double again the content of SOI into your smartphone. And you have also some additional feature and communication applications such as Wi-Fi or ultra-wideband that can be built on SOI substrate. So now in terms of products, so the product called RFSOI or RFSOI is this product with a top silicon thickness in blue. Then you have a buried oxide. We have a specific trap-rich layer highlighted in red onto a high resistivity handle. So this trap-rich layer actually is really key for this technology because it actually suppresses the parasitic surface conduction you have, and because it blocks the fixed charge into your devices. So what kind of benefits you have on your device? On the right-hand side, you have some RF performances we are measuring actually on our SOI substrate. We are putting, as showing on the scheme here, the line, a coplanar waveguide, and then we apply a RF input signal, and we look at the output of this RF signal. And here, what is important to know, if we are, for instance, at 15 power output, you can see that the red material, which is called HRSOI for high resistivity SOI, but without this trap-rich layer, you ended up with like 60 dBm of second harmonic. And the higher in terms of negative value you are, the better you have in terms of linearity, so in terms of RF performances of your device. So then, if you add this trap-rich layer, you decrease, so either down to minus 80 dBm, what the product we call RFSOI 80, or even 90, actually, if you increase the resistivity of the handle material to achieve this performance. So this trap-rich layer is really an enabler of this RFSOI product and guarantees the excellent RF performances. Then, for the RFSOI substrate, you have all the different layers and the substrate specification associated to them. And these specifications actually are in addition to the benefits that are required at the device level. So, for instance, if you are really sensitive to electrostatic, thickness and uniformity of the different layers are really key. If we talk about variability, also the micro-roughness of the material is key, as well as the quality of the buried oxide, and so on. And we have actually 30 years of experience of producing SOI material, but we are actually also close collaboration with our supplier to ensure the best performances of this material. And we need some development cycle to guarantee actually the continuous improvement plan of this product and performances. So as a conclusion, actually on the left-hand side, you have our standard RFSOI product in high volume manufacturing that is right now in all your smartphone. And within the Beyond 5 project, actually we have developed and we are still developing some new products called AFM SOI. So this is a product really focusing on all the cost aspect and the cost-effective solution versus the performance of the RF devices. For that, actually, to address the Wi-Fi and IoT application. And what is the key, especially, is to develop a new trap-rich layer which is thinner. And on the right-hand side, the other RFSOI product we are developing, so as mentioned before, it's more targeting some automotive application in terms of connectivity in your car, especially when you need to have this, to guarantee these RF performances at a higher temperature. And for that, we are actually developing some new material, also as a new trap-rich layer, to enable these performances at higher temperature. So in conclusion, we as Soitec, we have a product which is called RFSOI or RFESI for 4G application, and we are developing some new material for 5G and millimeter wave application. Thank you very much. I think we have like 1 or 2 minutes for question.
Yes. Is there any question?
Everything is crystal clear.
Okay.
Yes.
Yeah, you have one?
Wait a second, we need the mic to get it on the film as well. Thank you.
Hi, my name is Magnus Ride. A question I have is on the third box, the trap-rich environment there that gives you the extra performance.
Yes.
Is this IP of yours? Do you have good IP covering that technology?
Yeah. And we actually also, we have IPs, and we are also exploring different material approach in collaboration also with CLAT, that is our partner in terms of development of this new material.
So that's where the technology was developed?
Yeah.
Okay, thank you.